my name is Professor Rad, and in this video we'll be practicing all our concepts so far about real numbers. And we're going to do that just by answering a few true-false questions. Now, be careful with true-false questions. These are always a little bit deceiving because, like, I remember whenever I was a student and I saw a true-false question, I was like, these are meant to be done really quickly because it's just like true, false, boom, 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 boom. That is actually not the case with math, because in math, definitions are really important because you have to understand your objects, so you understand how those interactions apply or what you can do with that number or not. So you have to be really careful with true-false questions because there are a lot of things that look really similar, but they're different. So we're going to take our time with these. We're not going to rush through them to make sure we get them all correct. So I'm going to stand aside. If you want to pause the video here and practice your own understanding, you can feel free to do that. All of these are based off of the last, I think, 3 videos that we looked at. So yeah, if you want to pause, work through these, and then unpause, we'll work through them together. If you're still feeling a little bit shaky or you're not certain, then we can just walk through them together now. Okay, so let's go through them. So we have to decide whether each of these is a true or a false statement. So for part A, it says, in this number, the 3 is in the hundredths place. So this is an identifying place value situation. So the first thing I'm going to do before I even start to break down the question further is figure out where the ones place is, because that helps orient where my place values need to be. So look for the decimal point, and immediately to the left of the decimal point is the ones place. So next, we're interested in the 3. So I'm going to underline the 3. Now I'm noticing that this 3 is to the left of the ones place. So that means it's in a whole number place value, which means it's going to end in an S when like not a THS, just an S, because it's a whole number place value. And I could figure out the place value by counting. So here's my ones, and we have tens, and then this is going to be the hundredths place. So let's see what the statement said. It said the 3 is in the hundredths place. So we've identified it to be in hundredths, and they're telling us hundredths. So it's fun to say, isn't it? So this one's going to be false. I'll write my answers over here. False. Because we're in the hundredths place, not the hundredths place. So this is what I mean. Let me get out of the way of the answer here. This is what I mean by being very careful when you're working through true-false questions. They tend to be a little bit tricky like that, where it's almost the right answer except for that TH. So in part B, we have another similar kind of question. We have a digit and we're looking for its place value. So identify where the decimal point is. That's going to help us find the ones place. And we're interested in the digit 8. So this time the digit we're interested is on the right-hand side of the decimal point. So this is our ones. Immediately to the right will be tenths, and then we have hundredths. So this is the hundredths place. Sorry about my squeaky marker there. So we have the 8 here looks to be in the hundredths place. The 8 is in the hundredths place. So now being careful in comparing them, hundredths, hundredths, that one is a true statement. So B is going to be true. Let's take a look now at part C. So it says the number 600ths is written 0.06. So this one is trying to help us figure out whether our decimal and word matches up. So to work through this one, think about what is easier for you. Is it easier for you to go from decimal form into words or from words into decimal form? And use that direction to help guide you in solving this problem. So for me, I'm going to go from my decimal form into words. So I'm going to write 0.06 in words and see if it matches up with what they told us. So to write a decimal in words, you're going to say the whole number part first, followed by and. So in this case, our whole number part is just 0. So we can skip that step. So we don't write 0 and. Then we're going to treat everything to the right like it's its own number. So I have 0, 6. Now, when you have a 0 in front of a number, remember this is like if your clock is telling you it's like 12:06, right? So that 06 just means the same as 6. So I'm going to start out by writing 6. And then to finish, you want to state the place value of the last digit. So this is the last digit in our decimal number. So the 0 here is in the ones place because it's immediately to the left of that decimal point. And then we'll count the place values. We have tenths, hundredths. So the 6 is in the hundredths place. So the name of 0.06 is going to be 600ths, which matches what they have here, 600ths. So there we go. C is going to be true. All right, let's work our way through part D. So in part D, it says the numbers 15.040 and 15.4 are the same number. So when you see a question like this, they're trying to work us through those necessary and unnecessary zeros. So can we remove all of the zeros in this number and therefore get 15.4? So to check that, remember that a 0 is not necessary if it's all the way to the right after a decimal point. If it's the last digit to the right of a decimal point, then we can get rid of it. If it's in the middle somewhere, or if it's to the left of a decimal point, then it's necessary. We have to keep it. So when I look at 15.040, this 0 is the last digit. Hi, kitty cat. It's the last digit, and it's all the way to the right of my decimal number, which means that I can get rid of it, and I can rewrite this as 15.04. I'll be with you in a minute, kitty. Okay, so sorry about that. So here we have 15.04. Then to see if this 0 is necessary or not, you want to see if it's at the end of the decimal point, right? So it's not. The 4 is the last digit all the way to the right of the decimal. So that means we have to write that 0. So we can rewrite 15.040 as 15.04, which is not the same as 15.4. So these are not the same numbers. This one is 15 and 400ths because the 4 is in the hundredths place, while this one is 15 and 4/10ths because the 4 is in the tenths place. So part D here is going to be false. All right, let's take a look at part E. Let me fix that number that I partially erased there. This one says the real number 0.172 is also a whole number. So this one is testing two concepts, really. Concept one is it's testing on the surface the different number names. So can we tell the difference between a real number and a whole number? The second concept it's testing is the unnecessary zeros. So when I look at 0.172, there's no way for me to write this without that 0, because we've got that 0 point, that 0's to the left of the decimal point, so it's necessary. So this is going to be the main way we want to write this number, 0.172, or 172 thousandths would be the name of this number. To see if we are a real number versus a whole number, we are a real number if we're any number, basically. So any number you can think of right now, that's going to be a whole number. Or a real number, I'm sorry. Any number that you can think of is going to be a real number. To be a whole number, we have to have no decimal part. We have to be something we would have if we were counting, like 15, 16, 138, things like that. So I would not say 0.172, right? I wouldn't say 0, 0.172, 1, right? It's not a number we use when counting. So this one is not a whole number. So this is not whole. So part E here is going to be false. All right, let's take a gander at part F. So in F, it says the number 17 and 200 thousandths, or 17.200, has two unnecessary zeros. So let's check this one out. So remember, I'm an unnecessary zero if I'm all the way to the right and I'm after a decimal point. So this 0 is all the way to the right, and it's after the decimal point, so we don't need it. It's unnecessary. That would turn this number into 17.20. And then to see if this zero is unnecessary, we do the same check. So it is all the way to the right, the last digit on the right after decimal point. So that means it is unnecessary. And we can rewrite this as 17.2. So we found that there were 2 zeros we didn't have to write. So that meant there were 2 zeros that were not necessary. So this statement is going to be true. All right, we have one more to work through. So part G says the real number 172.00 is also a whole number. So this one's going to be similar to part E. And once again, we're going to check out the zeros to see if they're necessary or not. So here we have this first zero. It is the last digit all the way to the right, and it is after a decimal point. It's to the right of a decimal point. So we can X it out, and we can rewrite this as 172.0. And now we repeat this zero all the way to the right. It's not necessary because it's to the right of a decimal point, and it's the last digit. So we can get rid of that. And we can rewrite this number as 172. Now remember, once we get rid of everything that's on the right-hand side of the decimal point, we no longer have to write the decimal point. So we could just write it as 172. So this means that 172.00 is the same as 172. So notice there's no decimal piece now on this number. It's just the whole number part. It's just the 172. So because it's just the whole number part, that means it is a whole number. So this whole number 172 is a real number. In fact, every whole number is also a real number because you can rewrite it with some extra unnecessary zeros if you wanted to. So part G is going to be true. All right, so that's going to wrap it up for these examples. After this, I have a list of some Now You Try problems, so you can work through some extra true-false questions. The answers will be in the description as always. While you're working on that, I'm going to go check on Lenny and check on my cat, make sure he's okay. So I hope you all have a wonderful day. In the next video, we're going to start rounding decimal numbers, so we'll talk about that process. So yeah, have a wonderful day, and yeah, bye for now.